Hello everyone. So today we are going to discuss the salt hydrolysis. Okay, salt hydrolysis. What do you mean by salt hydrolysis? So the term itself indicates that salt is getting hydrolyzed. Actually, salt is formed by what? Salt is a combination of acid and base. So here the actual definition of salt hydrolysis is the anionic or cationic part of salt interacts with water to form corresponding acids or bases. Okay, corresponding acids or base, acid or base. Okay, acid or base. Okay, so we know salt is a combination of acid and base. Okay, so we are having salt strong and weak concepts, right? Strong acid, strong base, weak acid, weak base. So by the combination of these four, by combination of four of these strong acid, strong base, weak base, we can have different salts, right? So let us take the first combination, that is strong acid and strong base. Just focus on this one, strong acid and strong base. Strong acid and strong base. Okay, so examples of strong acids are what? We all know HCl is a strong acid, H2SO4 is a strong acid, HNO3 is a strong acid, right? So many are there. And strong base, if you take the first A group elements, first A group hydroxides, alkali metal hydroxide, sodium hydroxide, lithium hydroxide, potassium hydroxide, and second A group hydroxides also, like magnesium hydroxide, calcium hydroxide, etc. These are all strong bases. So here this H plus and Cl minus. So this is also having H plus and Cl minus. Cationic part and anionic parts are always there. This for Na plus and OH minus. So here in this case, so when you mix this HCl plus NaOH, what happens? It forms a salt, that is NaCl plus water, right? So this NaCl is a salt of what? Strong acid and strong base. So and we are also having water here. This Na plus and Cl minus, which are from strong species, will not get hydrolyzed. Instead, they can be hydrated. Okay, they can be hydrated, but they do not interact with water. So that is the reason we do not study the salt hydrolysis of strong acid and strong bases. Okay, so the any species from strong will not hydrolyze. Okay, only weak species will hydrolyze. So here, so we can have four combinations. Salt hydrolysis of four combinations. First one is strong acid plus strong base. Okay, salts of strong acid plus strong base. I'm writing salts. Okay, so first one is salts of strong acid plus strong base. Okay, second one will be what? Salts of salt. Okay, no, don't take salts, let's take salt. Okay, salt of strong acid plus weak base. And third one, salt of weak acid plus strong base. Fourth one is what? Salt of weak acid plus weak base. Okay, so anyhow, this first category, that is salt of strong acid and strong base, will not hydrolyze. Okay, therefore we do not study. But here the salt of strong acid and weak base, they can undergo hydrolysis. Okay, this weak part is there now, weak base. So this part reacts or interacts with water and they get hydrolyzed only. Okay, and here specifically cationic part or anionic part only reacted with water molecule. Okay, so let us start the salt of strong acid plus weak base. Okay, strong acid plus weak base. First one, that is salt of strong acid plus weak base. Okay, so strong acid is what? Strong acid is HCl. Weak base is what? Let us take ammonium hydroxide, NH4OH. Okay, they combine and form what? NH4Cl plus water. Okay, now you can see here chlorine and ammonium. So NH4 plus and Cl minus. Which one is from strong species? HCl we are having. HCl is a strong acid here and ammonium hydroxide is a weak base here. So this chloride ion is from strong counterpart, right? This is from strong species. So this will not undergo hydrolysis. Okay, so in fact these are called as spectator ions. Spectator ions. They do nothing. Okay, they do not interact with water molecule, but this cationic part is there na, NH4 plus. This cationic part interacts with water. NH4 plus water gives NH4OH base. Okay, because it is positive, it interacts with OH minus and forms NH4OH, and the remaining is what? H plus. So now you can see H plus is being released into the solution. Means what? The solution turns acidic. So this can be confirmed by what? Litmus test. So if you do a litmus test, the litmus test, it turns blue to red. Okay, it turns blue to red. So you can confirm that the solution will be acidic. Okay, so here we are talking about hydrolysis of this salt. So the constant we get here, it is called as, okay, it is called as what? Hydrolysis constant, KH. Okay, and here we are also having water, H2O, which can also undergo self-ionization. It forms H plus OH minus. Okay, so we are having NH4OH weak base. It can also undergo ionization and form NH4 plus OH minus. Okay, so this dissociation is called as KB because base dissociation, and here it is self-ionization of water, that is called as KW. Okay, so actually this weak base will not undergo complete ionization, complete dissociation. Okay, but they can go very to less extent, and we can consider that equilibrium as well in the salt hydrolysis. Okay, now I am writing the main equation, that is this one only. I am repeating again here. NH4 plus water, it is forming NH4OH plus H plus. Okay, so if I take initially C moles of NH4 plus are present, and we do not care about water, and NH4 will be what? NH4OH will be 0 initially at time t equal to 0. Okay, at equilibrium, what happens? CH moles got dissociated, and CH moles got dissociated. In CH moles of products are formed, means here what? So we have to subtract this from concentration. So C minus CH moles of ammonium are present at equilibrium. If I write the hydrolysis constant for this one, so how can I write? It is just like equilibrium constant only. Okay, it is the product of products concentration divided by reactants concentration. Okay, so NH4OH into H plus divided by NH4 plus. We do not include what? H2O, because it is hydrolysis constant. Okay, so CH, concentration of NH4OH is what? CH, and here it is also CH, and we are having C. If you take common, 1 minus H. Okay, C gets cancelled, and it can be written as CH square by 1 minus H. Okay, so if hydrolysis degree of hydrolysis is very less, that if H is very less than 1, then we can write 1 minus H is nearly equal to 1. Okay, at such times what happens? So KH will be equal to CH square, right? KH will be equal to CH square. From this I can write the degree of hydrolysis H equal to under root KH by C. So remember this H is equals to what? It is a degree of hydrolysis, where KH is what? Hydrolysis constant. Okay. Yeah. So KH by C. So we have also seen the dissociation of base here and dissociation of water. Now I can write this the hydrolysis constant in terms of dissociation of water and dissociation of base. So in fact I can write this KH as KH will be equal to KW by KB. So let us test this whether it is correct or not. KW is what? Concentration of H plus to concentration of OH minus, and Kb is what? It's a dissociation constant of base, right? So ammonium hydroxide dissociates as what? Ammonium NH4 plus and OH minus, and the denominator goes upward, that will be NH4 OH. These are all aqueous forms, okay? These are all aqueous forms. So you can just correlate this one, okay? So OH minus gets cancelled here and remains what? NH4OH into H plus by NH4 plus. So let us check. NH4OH into H plus by NH4 plus. So this is correct. Okay, KH will be equal to KW by KB. And I got what? Degree of hydrolysis as root KH by C. So now I can write degree of hydrolysis as root KH by C, right? We got KH by C. This can also be written as root KW by KB into C. Okay, just I have added KW by KB in place of KH. Okay, so this is degree of hydrolysis. So if I want to know the concentration of H plus here, so what is the concentration of H plus? This is the concentration of H plus, CH. I can write concentration of H plus is equal to, I'll use another color, concentration of H plus. So let us write with black. Concentration of H plus. So concentration of H plus will be equal to C into H, right? We are having H as what? KW by KB into C. We are having H value as this one. Okay, so now I can write this as C can be written as root C into root C, right? Root C whole square is C, and this is root KW by, I'm splitting root KB into root C, right? So root C gets cancelled, and so this can be written as root C or KW into C by KB. Okay, KW into C by KB. So this is what concentration of H plus. If I want to calculate pH, so how can I do? So minus log H plus. I just have to do anti-logarithm of H plus. So this could be equal to minus log of concentration of H plus is what? KW into C by KB whole to the power of 1 by 2. I just have removed square root. Okay, this can be written as minus 1 by 2 log KW. Log A into log B is what? Log A plus B. So minus sign is there. So minus 1 by 2 log C. And log A by B is what? Log A minus log B. Already minus is present. So log KB. 1 by 2 KB. Okay. 1 by 2 we have to write. Plus 1 by 2 log KB. Okay, so ionization of water at 25 degrees centigrade is what? 10 to the power of minus 14. Therefore, I can write here minus 1 by 2 log 10 to the power of minus 14 minus 1 by 2 log C plus 1 by 2 log KB. Okay, so this becomes what? 14 by 2, 7, right? 14 by 2, or you can write like this one. Okay, 1 by 2. Okay, minus into minus becomes plus. So 14 minus 1 by 2 log C. Okay, I'm writing plus 1 by 2 log KB minus 1 by 2 log C. So this 1 by 2 log KB is what? I can write this as PKB, right? So anti-logarithm of KB is PKB. Here it is plus. So I can write this as minus, right? 14 minus PKB minus 1 by 2 log C. Sorry, don't include my 1 by 2 here again, because already we have taken common. Okay, log C. This is the expression. 1 by 2, 14 minus PKB minus log C. Or if you want to simplify it, you can write this as 7 minus 1 by 2 PKB minus 1 by 2 log C. So you'll get what? pH is less than 7, because the next term is negative. Less than 7 minus means less than 7. So the pH will be, pH is less than 7. Therefore, the solution will be acidic. Okay, so this is how we derive the concentration of H plus and concentration and hydrolysis, degree of hydrolysis, and KH, and also the pH for the salt of weak acid, strong acid plus weak base. Now let us see the other one, that is second one, salt of weak acid plus strong base. Okay, we have completed strong acids combination, and let us do weak acid weak combination. Okay, strong acid strong base will not undergo hydrolysis. Strong acid plus weak base we have seen, and weak acid plus strong base. Now let us see. So weak acid is what? The example of weak acids, many are there. Okay, best example, the common example is what? CH3COOH. I'm writing CH3COOH here. CH3COOH is a weak acid, and strong base is what? NaOH. Usually we take this one, and they form CH3COONA plus H2O, right? CH3COONA plus H2O. Now you can see CH3CO minus and Na plus. So which one is from strong? Sodium hydroxide, right? Sodium is from strong. So this is a strong part, strong, therefore do not hydrolyze, and the remaining is what? CH3CO minus is present. So CH3CO minus reacts with water and it captures what? H plus, because it is negatively charged. CH3COOH, and it releases OH minus ions. So you can see as it is releasing OH minus ions into the solution. So the solution could be basic. So how do you confirm? Red to blue. There blue to red, and here red to blue. So same here also. H2O is present. H2O undergoes dissociation, right? Self-ionization, it forms H plus OH minus, and here acetic acid is present. It undergoes dissociation, CH3COO minus plus H plus. This is Ka, this is Kw, and this is what? KH. Okay. Now let us write the main equation, that is CH3COO minus plus H2O will give rise to CH3COOH plus OH minus. Okay, initially what? Initially if C concentration is present, here 0 moles will be formed. At time T equal to equilibrium, so CH moles got dissociated, then C minus CH I'll get. Okay, so if I write the KH for this one, what it will be? It would be what? Concentration of acetic acid, CH3COOH, into concentration of OH minus divided by concentration of CH3COO minus. So this I can write it as CH into CH. Again we'll get the same, C1 minus H, CC gets cancelled, CH square by 1 minus H. This can be written as KH if 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 H is very less than 1, degree of hydrolysis is very less, then we can write 1 minus H is nearly equal to 1, then KH will be equal to CH square. From this, degree of hydrolysis can be written as under root KH by C. Okay, so here we can write this KH in terms of same ionization of water and dissociation of weak acid here, because weak acid is the main part. Okay, so in fact it can be written as KH is equals to KW by Ka. Let us test it. KW is what we have, concentration of H plus and OH minus, and acetic acid dissociation is what? First you have to write ions CH3CO minus 2H plus, this goes up CH3 COOH, right? So from here you can see where here this Ka, okay, CH3CO minus by CH3CO minus H plus by CH3COH. So H plus gets cancelled, the remaining will be what? OH minus into acetic acid by acetate. So let us check KH, acetic acid into OH minus by acetate. So we got the correct one. Okay, so we can write KH as KW by Ka. So we got H is equal to what? KH by C. So I am substituting KH value here. Now H becomes under root KW by Ka into C. Okay, KW by Ka into C. This is H concentration. Okay, so here we are going to get OH minus. So first of all, we have to calculate OH minus, and then we have to convert that into H plus concentration, because acetic acid is there, right? So we can calculate from this H plus. Okay, so now let us write concentration of OH minus ion will be equal to CH. Yes or no? Yes. So here we got what? CH. This CH. So OH minus ion is equal to CH. This can be written as H value in KW by Ka into C, and this CC gets cancelled. So in numerator magnitude we will be going to introduce. So KW into C by Ka. Is this correct? Yes. So this is the concentration of OH minus, and we know H plus into OH minus is equal to KW, which is called as ionic product of water. From this, I can write concentration of H plus is equals to KW by concentration of OH minus. Okay, so now I am going to substitute here. That is KW by OH minus. So concentration of H plus will be equal to KW is what? KW is KW only. Okay, KW by OH minus is what? Root KW into C by Ka. Okay, so KW, root KW, root KW. So this I am elaborating it. Root KW into root KW divided by root KW into root C into this will go up to root Ka. 1 gets cancelled and it forms root KW into Ka by C. Okay, this is the concentration of H plus directly. Okay, so if you want to know what antilog of H plus, if you want to calculate pH, we just have to do what? We have to apply log. So minus log of concentration of H plus will be equal to minus log of KW into Ka divided by C whole to the power of 1 by 2. Okay, so this can be written as minus 1 by 2 log KW minus 1 by 2 log Ka plus 1 by 2 log C. Okay, so minus 1 by 2 log 10 to the power of minus 14 minus 1 by 2 log Ka plus 1 by 2 log C. Okay, so 14 is what? Minus minus gets positive. So 1 by 2, 14. So antilog of Ka is what? Pka, therefore plus Pka plus 1 by 2 log C. If you want to calculate 7 by 2, so 14 by 2 is 7. So 7 plus 1 by 2 pKa plus, this is not 1 by 2. Here we should not write 1 by 2. Okay, so 7 plus 1 by 2 pKa, 1 by 2 log C. So what can you see? pH is greater than 7 means pH is greater than 7, therefore solution will be basic. Okay, so this is about the salt of weak acid and strong base. Now let us see the the salt of fourth category, salt of weak acid plus weak base. Both are weak, so both involve in hydrolysis. So weak acid example is what? Same CH3COOH. I'm going to take CH3COOH. Okay, CH3COOH. And weak base is what? NH4OH, which reacts and they form CH3COO minus, sorry, CH3COONH4 plus H2O. Okay, so this CH3COO minus plus NH4 plus in the ionization form, the ionic form, they interact with water separately and they form CH3COOH acetic acid and NH4OH ammonium hydroxide base. Okay, so same here you can see what this water undergoes hydrolysis KW H plus OH minus. Okay, acetic acid undergoes dissociation, can be written as CH3CO minus plus H plus. NH4OH also undergoes hydrolysis, KB can write NH4 plus OH minus. Okay, directly I'm writing. So if I write the main equation, you can write KAKB here only. If you want, you can write here. KW is equals to concentration of H plus into OH minus. Okay, and Ka is equals to, you can write it later or now itself. It is of your choice. CH3COO minus into H plus. Okay, by CH3COOH. To remember, actually, just to remember, I'm writing here NH4 plus OH minus divided by NH4OH. Just to remember, I'm writing here. You have to write after the equilibrium only. Okay. So let us write the main equation. What is the main equation? This is the main equation. So CH3COO minus plus NH4 plus combines with water, interacts with water. It forms acetic acid, CH3COOH plus ammonium hydroxide, NH4OH. So initially, C moles are present, C mole products are present, and no products. At time t equal to equilibrium, what happens? CH moles, let us take H moles got dissociated. So this could be CH and CH. So this will be C minus CH and here C minus CH. So if I want to write KH, KH could be what? Concentration of acetic acid CH3COOH into concentration of ammonium hydroxide NH4OH divided by concentration of acetate CH3CO minus into concentration of ammonium NH4 plus. This is equal to CH into CH by C into 1 minus H common and again C into 1 minus H. C gets cancelled, C gets cancelled. So H square by 1 minus H whole square. So if H is less than 1, then 1 minus H nearly equal to 1. Therefore 1 minus H square is also 1. Okay. So KH becomes what? H square. Where is this? Yes. So KH becomes H square, and if you want to calculate degree of hydrolysis, H is equals to root KH. Okay, H is equal to root KH. So here if you want to calculate concentration of H plus, how can we calculate? Because H plus ions are not there individually, so we can calculate it from Ka. Okay, so we can calculate, I think in the last class I have said we can calculate H plus from there. No, in the last class we have calculated H plus, from ionic product of water. By using that equation we have calculated, right? So here we are going to calculate H plus using dissociation constant of acid. Okay, so before that, I need to write this KH form in ionization of water. I mean, ionic product of water and dissociation of acid and bases, right? So this KH can be written as KW by Ka into Kb. So let us test this, whether it is correct or not. Concentration of H plus into concentration of OH minus divided by first dissociation constant of acid, right? Ions CH3CO minus H plus. In the denominator, write the reactant, that is CH3COOH. Okay, and here Kb ions first, NH4 plus OH minus, and in the denominator the reactant of that is NH4OH. Okay, so which one will get cancelled? H plus gets cancelled, OH minus gets cancelled. The remaining will be what? So same acetic acid, the products in the weak acid, weak base salt hydrolysis, NH4OH by acetate CH3CO minus and NH4 plus. Just look at here whether it is correct or not. So KH, where we have written here, acetic acid, NH4OH by their ions. So same acetic acid, NH4OH by their ions. Okay, so we can write KH as KW into KA by KW by K into KB. So we got H is equal to root KH, right? Degree of hydrolysis is root KH. So H is equals to under root of KH. This can be written as KW by KA into KB. Why? Because KH is KW by KA into KB. Now, if I want to calculate concentration of H plus, how can I calculate? I can calculate this concentration of H plus from weak acid. Okay, so let us write the dissociation constant for weak acid, Ka, that is Ka equal to what? I'm using another color. Okay, Ka is equals to what? It is dissociation of acid, that is concentration of CH3CO minus into concentration of H plus divided by concentration of CH3COOH. Okay, so because we know the ions concentration, so you can see here, we know the concentration of acetic acid and its ion. So that is the reason we are using this equation. Okay, from this we can calculate H plus. So H plus is equals to, so Ka into acetic acid, that is CH3COOH divided by CH3COO minus. Okay, so concentration of H plus is equal to, I'm writing here, Ka into concentration of acetic acid is what? Concentration of acetic acid is CH, and the concentration of acetate is what? Acetate is C minus CH. So CH by C minus CH. This could be equal to CH by C common 1 minus H. Okay, so CC gets cancelled. This will be equal to Ka into H by 1 minus H. So if H is less than 1, then 1 minus H is nearly equal to 1. That is, if degree of hydrolysis is very less, so we can neglect H value, that is 1 minus H is nearly equal to 1. So now concentration of H plus becomes what? It is equal to Ka into H. So we know Ka into H. So H equal to what we got? we got Kw by Ka into Kb. Now we are going to substitute that. Okay, in another color I am writing. So concentration of H plus will be equal to Ka into H is what? Root Kw by Ka into Kb. So this can be written as, so if you split this, root Ka into root Kw divided by root Ka. So I can write this K as root Ka 2 times that root A whole square. Root Ka into root Ka. Okay, so root Ka into root Ka and root Kw is there. Okay, root Ka into root Kb. So Ka gets cancelled. So I can write this as Ka into Kw by Kb. This is what the equation I got. So if I want to calculate pH, just apply minus log, right? Minus log, then it becomes pH. So minus log of concentration of H plus will be equal to minus log of Ka into Kw by Kb whole to the power of 1 by 2. 1 by 2. Okay, so what it forms? Minus 1 by 2 log Kw. Okay, first I'm writing Kw. Then minus plus, right? So minus 1 by 2 log Ka plus 1 by 2 log Kb. Okay, so minus 1 by 2 log 10 to the power of minus 14 minus 1 by 2 log Ka plus 1 by 2 log Kb. Okay, so this can be written as what? Where is this? Yeah, so 14, right? So 1 by 2 if you take 14 minus 1 by 2 log K, antilog of K is what? pKa, right? So plus pKa I'm writing, and plus 1 by 2 log Kb, if I write pKb, should be minus, so minus pKb. This is the value we are going to get. If you want to solve this one, you are going to get 7 plus 1 by 2 pKa, in an order you can write, yeah, pKa minus 1 by 2 pKb. So you can also notice this one. So initially in the hydrolysis, so the hydrolysis of strong acid plus weak base, what we get? pH is less than 7, right? So weak base we have used, so dissociation constant of weak base Kb, that should be less than 7, so minus 1 by 2 Kb. So same minus 1 by 2 Kb here we got in the dissociation or in the hydrolysis of weak acid strong base, we got pH greater than 7, positive Ka. So here also same positive Ka and 7. So this is how we calculate pH for different acids. So let us conclude by writing all of them at once. Okay, so just I'm writing here. Okay, so strong acid, stronger base we don't take. Okay, strong acid plus strong base, no hydrolysis. So strong acid plus weak base, one combination, and weak acid plus strong base, weak acid plus weak base. Okay, so here, so first write degree of hydrolysis, that is H. H is equal to root K H by C, same here also same, H is equal to root K H by C, but here H is equals to root KH. Okay, so here you can see this concentration is not, term is not there, therefore upon dilution what happens? So if I dilute this weak acid plus weak base, there could be no change in degree of hydrolysis because concentration term is not there, it is independent of concentration. So you can do hydrolysis here, there could be no change in hydrolysis, degree of hydrolysis. Okay, next this is about H. Next, what else? Concentration of H plus we have to write. So concentration of H plus, what we got? So there, that could be Kw by Ka into C. Okay, and here concentration of H plus is what? Just reverse Kw into, so sorry, first we have to write Kv here because weak base rate. Kw by Kb into C. Here Kw by Ka into C. Just interchange. If you want to check it once, you can check it once. Okay. Where is this? Salt hydrolysis. Yeah. So Kh by C we got, and Kw into C by Kb. So this is first one. Kw into C by Kb. Kw into C by Kb. So here we have written wrong. Kw into C to C by Kb. Okay, here we have written correct. Kw into Ka by C interchanges, and whereas here, here what happens? Here concentration of H plus becomes what? Simply, what we got? Ka into Kb, Kw by Kb, Ka into Kw by Kb, Ka into Kw by Kb, Ka into Kw by Kb. That's it. And pH here it is what? It is less than 7. So 7 minus 1 by 2 pKb minus 1 by 2 log C. Whereas here, so pH is greater than 7. pH is equal to 7 plus 1 by 2 pKa acid. So plus 1 by 2 log C. But whereas here, okay, so pH is equals to 7 minus 1 by 2 pKb. Okay, plus 1 by 2 pKa. That's it. Thank you. Thank you. Two.